All right, so in your foldable where it says 11-1, you're going to write the title, which is Lines That Intersect Circles. So there's going to be a lot of vocabulary this chapter, but most of it should make sense to you. But basically, we're going to have circles, and you guys have all seen circles before. And then there's vocabulary like the interior of a circle, which just means inside. And then exterior of a circle, which is outside. And then there's, there's a radius, there's a secant, there's a tangent. So we're going to start off in your box that should say example number 1. And inside of it, we're going to start by drawing a circle. So draw a circle the best you can. And we're going to draw some pieces inside of it that's going to help get you your vocabulary. So the first thing we're going to draw is some chords, what we call chords. So a chord is a segment whose endpoints lie on a circle. Bless you. So you might have a segment that goes from one side of the circle to the other side of the circle. We're going to label it JM. And that's going to be our first chord, JM. Okay. Chords can also go through the center. So if you have a point right there, and if you have a segment going through it, it can also be a chord. So we'll call this one KL. So KL is also a chord. Happens to also be a diameter, right? You guys have already learned about diameter. Notice that KL is a chord and a diameter. Both. Okay, because it has endpoints that lie on the circle. It's a chord, but it also goes through the center, so which also makes it a diameter. All right. Now we're going to look at something called a secant. So a secant is a line that intersects the circle at 2 points. So if it goes through the circle and continues on and has arrows like this, we'll call this AB. The difference is the chord has endpoints and the secant is a line that's continuing on. So when you go to write its notation, you would say AB with arrows on the ends of it. Okay. Next one is a tangent. Tangent is a line in the same plane as a circle that intersects it at exactly 1 point. So it's going to look something like this, and it's going to intersect just right there. We'll call this line M. So line M is a tangent, just touches it in that one little spot. Okay. And then the last one is one that you should be very familiar with. It's radii or radius. Radii is plural for radius, right? So anything that goes from the center to the side. So if we label this midpoint L, oh, we already have L, J, K, L, M. How about N? We'll label it N. Then A radii would be NK. That's a radius, right? We could also go from N to L. We could even draw in another one right here and call it O, so NO. How many radii could I draw in there? A lot. Like in math, when you get a lot and you could keep doing more, that's called infinite amount. Okay? All right, so let's talk about Example number 2. We're going to have a coordinate plane. So if you can draw an X and a Y axis for me. Can I move it up, Cameron? You got it? You're caught up? Okay. You can draw an X and a Y axis. We're going to draw 2 circles in here. So the first one is going to have a center at -2, -2. So if you go 2 to the left and then down 2, 1, 2, we're going to call that point R. It's at -2, -2. From that center, we're going to go 2 to the right. From that center, we're going to go 2 up. From that center, we're going to go 2 to the left. And from that center, we're going to go 2 down. I just made 4 points around that center. And guess what I can draw through all 4 of those points? A circle, right? Mostly a circle. Hopefully with your pencil you can make a little better circle than mine. Okay, so this circle right here has a center at R, which is at -2, -2, and it has a radius of what? How many units? 2 units, right? Because we went 2 each direction. All right, let's put another one in here. So this one, we're going to go 2 to the left again, but this time we're only going to go up 1.5. So right here, we'll call this S, and its center is going to be at S, and it's at -2, +1.5, or 1.5. You can write it as a fraction if you'd like. And then from there, we're going to go, how far are we going to go? 1.5 units each direction. So I'm going to go 1.5 this way, 1.5 this way, 1.5 this way, 1.5 this way. Same thing. We're going to make a smaller, slightly smaller circle. So this one has a radius of 1.5 units. All right, now let's talk about our first theorem. So our first theorem has a number, and the number is 11-1-3. We're going to draw a picture for it, but let me read to you first what it says. It says, if 2 segments are tangent, hi.
Can I just put this here? Place this in my head.
Okay. If 2 segments are tangent to a circle from the same external point, then the segments are congruent. Okay? This is what our theorem says. So we're going to have a circle. We'll call it circle P. But we're going to have a point outside that circle. We'll call it A. And from that point, it's going to connect to the circle here, just where it touches it in one spot, and down here where it touches it in one spot. We'll call these points B and C. Okay? This theorem says that this external point is going to make these 2 segments congruent. So segment AB is going to be congruent to segment AC. That's our first theorem for chapter 11. Which leads us to example number 3. Oops, there we go. Okay, so example number 3. we're going to have a circle. We'll call it circle F. And we're going to have an external point way over here. And it's going to be connected to the circle like that. We'll call it point H over here, G up here, K down here. And now let me give you some measurements. So HG is going to be 4 plus 2A, and HK is going to be 5A minus 32. Okay? So the theorem that we just learned says that these two segments are congruent, right? So if GH said 7, KH would also be 7, right? Whatever one is, the other one would be. So if it was just a number, it would be super easy. If one was 22 inches, the other one would be 22 inches. But in this case, when you have an algebraic expression, like 4 plus 2A and 5 minus 32, you just want to take those two expressions, the 5A minus 32, and set it equal to the 4 plus 2A. And then we're just going to solve algebraically. So one of the tricks is, since we have the variable on both sides, is to get them on the same side. So I'm going to start by subtracting 2A from both sides, which leaves me with 3A minus 32 equal to 4. And then the inverse operation of subtracting 32 is what? Adding 32. So we have 3A equals 36. And then since the A is being multiplied by 3, the inverse operation is to divide by 3. So we divide both sides by 3. So our A is equal to 12. Okay, so if they ask us just to solve for A, we're good to go. But if they ask us, what is GH? We got to take that 12 and do what? Plug it back in. Technically, does it matter whether I plug it in here or here? No, because they're both the same. So pick the easier one. So I'm going to go 4 plus 2 times 12. So 4 plus 24. So this is 28 units. So what's KH? 28 units. Got two more theorems. One of them says this, Theorem 11-1-1. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So we're going to draw a circle. We'll call this circle A. And there's a line tangent to this circle. Whoops, can't see it. There it is. So we have our circle A. We have a point of tangency right here. We'll call it B. And here's what happens. If you connect A to B, that makes your radius A to B, right? But what also happens is it becomes perpendicular. So if we call this line L, call it whatever you want, you're going to say that line L is going to be perpendicular to segment AB. Yes? This one's 11-1-1. It doesn't matter which box you put it in. You've got 3. Just put it in any of the 3. Okay? And then the last one, 11-1-2, is the same as the other theorem, but it's just converse. It says, if a line is perpendicular to a radius of a circle at a point on the circle, then the line is tangent to the circle. So these two are going to essentially be the same, just converses of each other. So if you draw another circle, we'll call this one C. If you have a line tangent at D, if that tangent line is perpendicular, then the line is going to be tangent. We'll call this line M.